Hi everyone. So today we are going to start with an application problem. And it's very similar to the things we've been doing, just a couple extra steps. So it says the graph shows the cost of a smartphone plan. So notice over the data usage, as X increases, the amount we're paying for every single month on the smartphone plan increases. So sometimes think about your parents might give you limited data to use, and some of you guys might have unlimited data, and that price will go up. What is the y-intercept of the graph? So remember, for the y-intercept, you want to look at the y-axis and ask yourself, where does my line touch the graph? So my line touches at 0, 20, and therefore my y-intercept is 0, 20. What does that mean? So always ask yourself what each variable represents. The x represents data. So the 0 means 0 data. That means that we have to now look at the 20, which is the cost. It costs $20 if we don't increase our data usage, if we don't use any data. So $20 for no data use. Part B says, approximate the slope of the line and then interpret the slope in context of the problem. So to find the slope, you want to find first two nice pretty points and write out their coordinates. Now you could count rise over run, but it's a little more difficult when you have larger numbers and intervals. So I'm going to write it out as 0, 20 and 1,250, comma 60. Once you write down your two coordinates, label your x1 and your y1, your x2 and your y2, and find the slope. So so for your slope, you should have gotten 0.032, and we have to interpret it. So remember, our slope is a rate. So it's the cost, because we're looking at y being cost, per megabyte of data. Remember, we're looking at money. So if we wanted to convert that, that's about 3 cents, 0.03. I'm going to knock off that last number. So it costs about 3 cents per megabyte of data. All right. Write an equation that represents the cost as a function of data usage. So start off your problem with y equals. We know we need the slope x plus the y-intercept. So when we fill everything we know in, remember 0, a number, we already found that. That's our y-intercept. So that goes into this box. Our slope is 0.032, and that goes in front of your x. So 0.032x plus 20. Every megabyte you use adds 3 cents to your plan. Alrighty. Next problem says write an equation of each line with the given slope and y-intercept. So I would like you guys to try this on your own, as we've done a couple problems very similar to this, and then check your answer. All right, so for part A, you should have gotten -3 for the slope, so that goes in front of your x. So -3x plus 1/2, because your b value is your y-intercept. For the second one, I didn't finish it, so I can go over one thing, but you might have tried to put a 0 in front of your x. And notice, 0 times any number is just 0. So that disappears, and I'm just left with -2. Recall that a y equals equation is a horizontal graph. If I were to graph this, it would be a horizontal line through -2. Think back to Hoy. 0 slope, y equals a number, horizontal line. Okay, so this one is from a graph. So I know you guys have done this before as well. So let's go through one of these together, and you can try B on your own. So step 1, we need a slope m. So I'm going to count my rise over run. 1, 2, 3, 4, 5, 6. Run 1, 2, 3, 4. If you found two closer points, that's fine. Just make sure you simplify. M is equal to 3 over 2. Our y-intercept is where the graph touches the y-axis. So my b value is negative 3. Put your equation together in the form y equals mx plus b. M is 3 halves, and b is minus 3. Try the next. For this next problem, you should have gotten the slope as negative 3/4. So y equals negative 3/4 x plus your y-intercept, whoopsies, which is positive 2. Notice you might have written up 3, so positive 3, left 4, negative 4, and left your negative down here. That's okay, but please write them out like this. It's just formally how we write negative fractions on the outside, or put it on the top if anything. But if you want to use the slope, you may write it how you'd like to see it and use it. Okay, so these are just a little different than what we usually do. They tell us to find an equation that passes through the given points. So if I have 2 points and a line that passes through them, I can find the slope between those points and eventually the y-intercept. In these problems, the y-intercept is given. So look at both problems. Where do you see 0, a number? Those will be your b values. So in this case, my b value is negative 1 because my y-intercept, 0, a number, is 0, negative 1. In part B, my y-intercept is negative 5. So b is equal to negative 5. Now, I still have to find my slope for both of these. So we want to set up a slope equation. y2 minus y1 over x2 minus x1. So I plug in my values. M is equal to, if you want, you can label it, negative 1 minus 5 over 0 minus negative 3. When you simplify this, you get negative 6 over positive 3, which is equal to negative 2. Now I know my y-intercept, I know my slope, and I can write out my equation y equals mx, and so negative 2x, plus b, which is negative 1. Try the next one on your own. We have the y-intercept. You have to find the slope. Then put your equation together. All right, so I didn't finish the entire problem. I want to show you guys where to go from here in case you got confused or forgot some of your special cases. So on the top, negative 5 minus negative 5 is 0. So I have 0 over 8, which is just equal to 0. Now, you can go straight to writing your equation here and say, okay, that's 0x minus 5, and the 0x cancels, so my equation is y equals negative 5. However, it is very important to know these special cases because sometimes you get an undefined slope and it's not that obvious to plug in anything for m. So you want to remember that whenever you get a 0 as a slope, you're looking at the special case for horizontal lines. Horizontal line, 0 slope, it's always y equals a number. So when you do this, you go back to your y-intercept and you know automatically that is your equation. Y equals the y value, which is negative 5. You don't have to use your y-intercept. You can use any point they give you. Anytime you have a horizontal line, the y values will all be the same. So another way to recognize this is noticing that both y values are the same. This means that you have a horizontal line going through points that hit negative 5 on the y. That will always be a y equals equation. Before we start this point, keep in mind if you ever see problems where your x's are the same, and you're asked to write an equation of a line, you should automatically know that your slope's going to be undefined, and this is an x equals equation, which in this case it'd be x equals 3. We'll go over one of those examples in class as a warm-up. All right, so this one says write a linear function with the values f of 0 is 10 and f of 6 is 34. So if you recall, this is function notation. I would go straight to writing the coordinates out. The number in your parentheses is your x. The number it equals is your y. So your two coordinates are 0, 10, and 634. Step 1, find your slope. y2 minus y1 over x2 minus x1. That's equal to 24 over 6, which is equal to 4. I would box up your slope when you find it. Step 2, do you have a y-intercept? Do you have a b value? Yes, because you see the point 0, 10, and we automatically know 0, the number is the b value. So b in this case would be 10. Box that up when you find it. We have our slope, we have our y-intercept, and your final equation should be y equals the slope x plus the y-intercept 10. Right? The next page you can do completely on your own, as they kind of repeat the same concepts as the first slide. Same with this slide with 3 and 4. Try it for extra practice. 5 and 6, also extra practice. At the end of this video, you will see the answers for all of these slides. We're going to save 9 and 10 to do together as a warm-up in class. All right, so here's your answer for number 1 and number 2. Here are your answers for 3 and 4. Negative, or 3x minus 2 for number 5. And y equals a negative 1/4 x plus 9 for number 6. Again, number 9 and 10 applications will be nice little word problems for us.